Hello friends, this is Architect Ar.Gaurav, and we apologize for yesterday. We made an attempt to teach you through webcast about list commands, and we were posed with some technical difficulties. Today we are using Facebook options, and we hope for a successful webcast today. Okay, so I am founder of Parametric Curiosity, and Parametric Curiosity is a platform, educative and consultative platform for parametric architecture and design. And we always encourage people who are associated with parametric design industry to learn and grow. And we like to keep up with the latest tools and developments. And Grasshopper is one of the very good tools to use for parametric design, and it has many capabilities when you design parametric things. So it's a perfect tool, and today we'll be discussing about a very important topic. After you learn Grasshopper basic interface, the first thing you learn is about the lists, and lists are basically very important as every model you do for your design, it contains a list of data. So today we'll be starting from very basic, and let's start. Okay, so first of all, I would like to tell you what is a list, and to show that, let us grab a line. Okay, and then we go to the basic params tab, and then we take a container of a curve. So this is a curve container, and this is the geometry in Rhino. You can just right click, say set one curve, and then when you click it, it will show that there is a curve inside this container. You can hide the Rhino geometry, and you see that there is a red display of the geometry, and when you select it, it will become green. So it's a preview specific display setting. And then similarly, we can have one more curve, and we can again take a copy of this and again set a new curve here. And then we can again hide the Rhino geometry. So why I've taken these curves is because I want to generate some data to show you what is list. So whenever we divide a curve, you get set of points which can be represented in a form of list. So when you say curve and then you go to division, you have a option here for divide curve. And what does that say is you can give any curve the number of divisions, and then you can get the points, the tangents at those points, and the parameters. So let me put the curve. So by default, the count is set to 10, but we can change it. We can go to input and we can say number slider. And this number slider can be configured. And when you go, you can select integer numbers and then minimum and maximum range. So right now it will give you values from 0 to 1. But if we take the limit to 10, we can just plug in. So right now it's 0 and it's giving you no division. So as you increase, you can see the Rhino screen, you increase the number of divisions. And that's what we were wanting. We wanted to generate a list. And then if you come here, you see there are 4 values, in fact 5 values, and these are in form of list. To see this, you can go to again input and say panel, and when you take the points, you get a list. So first and foremost, what I would like to tell you is every list in Grasshopper, it starts with 0th index. So if you want to generate 5 numbers, you give a count lesser than 1 lesser than 5. So right now when you give 4, it gives you 5 values. If you give 5, you will get 6 points. So this is a basic list. Now let me tell you what are the components of list. So if you see, this is the list, these things, this is the list address. So this is 00 and it represents a whole list. And these numbers here, they are the individual addresses in this list address for each list item. So suppose you want to refer to this item. You want to refer to the second point, 0, 1, and second point, this one. So this would be the point. So its address will be 0, 0, address list, and from that list you get the second element. So that's how like the structure of the list works. So this is just for your basic understanding of the list, but you do not need to dive in right now into so much. It's just like you need to understand that these are the indexes. This is list item index. These are the list items, and this is the address. So for now, that's pretty much you need to know about it. Now, when we do the same thing for another line, we get two lists. Okay, so if we go and we say panel, and you can just say you get two lists, two different lists. Okay, now the important part is how these lists interact with each other. That's another point, because in Grasshopper or in any design while you're doing, you need to interact these lists in order to generate your geometry. So right now, suppose in the case we want lines from these points, respective points to each other, we need to refer these points. One more thing is, like, you might be wondering, what are these values in the list? These are actually the coordinates of the points. So this is the X, Y, and Z coordinate. So you can see there are 0 coordinates in the Z one because it's on the, right now it's on the XY plane, no Z value. And these are the coordinates. So right now, if you want to join 2 points to get a line, you need to say 0 to 0, 1 to 1. So how two lists work? So suppose this is list 1. We say L1. And this one is list 2. This is L2. And this is P1, P2. These are the like points, P3 and P4. Okay. And this one is suppose S1, S2, S3, and S4. So when you interact these lists, or like give a command and feed both of these lists, always the first element would interact with the first one, second one the second one, third with the third one, fourth with the fourth one. This is the way the parallel interaction, how it happens in Grasshopper. And suppose like you have to make a line here. So you go to curves and you go to primitive and you say line. And then you take the list of these points, and then you take the list of these points. And you see there would be lines from each other passing through. So this is how you can see like lists are usable. This is just a small example. When you later on make more geometries, then maybe you have like more data. Okay. So now this is the case when you have equal number of lists. Like you have 5 points in this list, 5 points in this line list. Now suppose if you have more number of points in this one and lesser one in this one, what would happen? Okay, so let's do that. Suppose you make it 10. Okay, and let me do one more thing, is display some numbers, which you can do with tags or point order, maybe point list. So you can say that these are the points, and then you can set a size like 4 maybe, or maybe 8. And then for same you can do for the another one. So you sort of see number of points. Now you can see how these points are interacting right now. So in this one, in this list, you have 11 elements, and in this one you have 6 elements. Now what happens is, when you have these lists in differentiate number, Grasshopper do data matching, and there are different types of data matching. Right now what's happening is the last element is joining with the remaining numbers. Okay, so that's the short list is joining the last element of the short list. It is joining to all the other elements which are left from the parallel interaction, which I told you earlier. So this sort of thing is called shortest list. So when you go in sets and you see there is something called shortest list. So suppose you pass your both list through this component, and then you say line. I think I've chosen a wrong one. Maybe there's the longest list. I'm just sure. List 1, list 2, start and end. Okay, so that's the longest list. Yes, which one it was showing by default. I'm sorry. This is the longest list. So in the longest list, every time you can choose longest list from here. So the last element would interact with all the other elements which are left. And if you take the shortest list, which we were talking about before, what happens is the shortest element, the last element, won't join to the other ends. Okay, then there is one more list matching, which is called cross-reference. What cross-reference does is it will take every possible connection of each list and join it together. So suppose you have list 1 and list 2, and you go to start and end. So you see every possible connection of 0 to other element, 1 to other element, 2 to other element. So that would be generated in the cross-reference list. So this is like just very basic of lists, but there is more aspect to it which I want to discuss. And for that, let us go to the default setting of the longest list, what it was doing, and maybe we make it equal number right for now, and then I will tell you about more list command. Now suppose you have these number of lists. So now if you take a panel, you have a new list of lines. So instead of points, you have 10 lines, each at a different angle. Now suppose you want to take the 5th line, 0, 1, 2, 3, 4 and 5. This is the 5th line. Okay, you want to take this, and you generally want to select this and extrude this. So what you'll do is you go to sets, and then you have these list commands here. So first of all, you say list item. Now list item gives you a particular item from a set of list. So suppose now you have a list of lines, you put this into the list command, okay? And then you need to know the index, okay? So right now by default it's a 0 index. So suppose we take a number slider and then again we configure it from 0 to 10 and index we give it. Now when you keep it selected, it will show you green element or the element which is inside this container. So now for the fifth one, you keep moving and you have the fifth element here. So right now, what you'll have in this would be the fifth line. And then maybe you can say extrude up, and then you can take this item and give a Z direction for the extrusion. And then you can again take number slider and tell how much to extrude, and then it would be, let me make this 100 maybe, then you would be able to extrude only that element. And that's what the beauty about Grasshopper is. It's parametric, so when you change, it will change the extrusion. Okay, every time you change the item index. So this is the pretty much script for right now, if you want to see, if you're following along. And when you change, keep changing it, it will give you a different thing. So that's called list item. That's very important one. Then suppose you have now list of lines. Now you want to know how many lines you've got. So it's showing you 11 locally defined values. But how to get this through Grasshopper, maybe. Let me make it a little bigger. Okay, so from Grasshopper, you again go to sets, you say list, and you say list length. And when you say list length, it will give you a number 11. So that means there are 11 values in this 11 number of lines in this list. So you can use this command also. Now, suppose you want to extrude, okay? You want to extrude this line according to the sets, okay? Suppose you want to take only first, second, and other onwards lines to extrude, and you want to exclude the 1, 0, 1. How would you do it? So you will take the list of the lines, and then you will go ahead and you will say maybe shift list, and this is shift list, okay? And from these list of lines, you can shift it with one number. So right now you have 0, 1, 2, 3, and if you say just shift the list by 1, the new list will start from this element. And then when you extrude this time, we'll see that, and yeah, you need to say wrap false. Otherwise it will come back to this. If you say wrap means like it will go back to the start of the list. So we don't want that. And right now, when you shifted the list from the first element by 1, then you have this. Now suppose you don't want even like these 3, you want to shift the list by 3. So you just go ahead and change this to 3. And then you see you have these another part of list. I hope everybody who is seeing this is following it along. I would just add a note. Thanks for everyone who's watching it or like. Thank you. So we go back to Rhino, and then after going to Rhino, I'll show you some more commands which are there. Just give me a second. Let me set up my laptop, which is posing some problem. Okay. So till here, I've shown you shift list and list length and list item. Now there is one more, which is like reverse list. And what does that do? Okay. So let me just get rid of this and this. And suppose taking this point and we reverse the list. And now if I show you the points, you can see like the 0 starts from there, first, second, 10, and it's reversed. So if you take this list, you will have this. So the 10th, the 0th element from this side is going to the 0th element of that side. And the first one to first, second one to second, and so the list is reversed. So that's the reverse list. And these are basically more or less the examples of basic list commands. Then there are some more which you can try, like partition list, in which you can partition list into two set of lists. And then there is sub list, split list, like you can split list into two parts. So you can try these, but for now, for our bridge exercise, I think we are good to go. And let me start with the example of modeling a bridge. Okay, so somebody is asking for attractive point and kinetic facade. Yeah, we will do a video later on that. Thanks, Mr. Elmisht. Sorry if I pronounce your name wrong. And we would do that for sure. And thanks, Marcos, for being in our session. And right now we are doing some basic lists. And this is also very helpful. So let us do this. And later on, yeah, we will do some more videos for attractive points for sure. Yeah. Okay, getting back to the bridge example. Okay, so we'll be doing a very basic bridge model, and that would be using lists, and you will see like why lists are important in modeling. So suppose we'll start with a very basic. Okay, let me take a curve from this point, okay, and let us copy this curve to we can say ortho now, and let me copy it somewhere around here. Okay, so now you have two curves. Okay, so right now first the plan of this bridge is like how I'm going to create is this is the base of the bridge. These two lines represent the boundaries of the floor of the bridge, and we'll try to create a truss over this curve and then that curve. Okay, so let us start. Okay, as we took like curves first, so let us start with the curves first, and we'll go to curve, primitive, or param, sorry, geometry, and we'll go to curves. Where is curve? Is here. Okay, and then we copy, Control C, Control V, one more, and then we reference the first curve, set one curve, and then we reference the second one, set one curve, and then we hide both of them in Rhino, and we have like two curves referenced in Grasshopper, curve 1, curve 2. Okay, so now what we'll do is we divide the first curve. Divide curve, as we do again, we can type it also, or you can go from curve, division, and you can have it from here. So you go to curve, and then you take a number slider from here again, and there is very interesting way to get number slider. That's a shortcut I'm telling you. It's like you double click here, and then you say shift, and you say colons, this one, and you say 10. So you get a panel, sorry, not this one. Double click, you write the lower limit of your slider, and then you say the lesser limit, and then 10. And then to get a slider from 10. So suppose you need from 3 to 20. So you type this and you say enter, and 3 to 20, you will get a slide. Okay, so that's just one of those tricks I was telling you. Okay, so right now let's take this one. Okay, so these are 8 points, and now what we want is we want to create a truss out of this, a square truss. So what we'll do is first we move these points up in the Z direction. So again, there's a list, and we can give a command to all the points at once, and we say move, and move can be found in the transform menu, and in utility in the Euclidean you will find move. And there's one more very important short trick. Again, I'll tell you, if you want to know where a component is located, you just say Control Alt, and then you click component, and it will show you where the component is located. Suppose you want to find out where the division is located in the upper tabs, you say Control Alt, and you click it, and it will show you that it's in curve menu, division tab. Okay, so when you say geometry, now this is asking you for a direction. For direction, we can take vectors, and then we can go to vector menu, and then we can take a unit Z vector. Okay, and then for Z vector, we should tell how much it should move in Z direction. So again, let us take a slider from 10 to 100 maybe. Okay, and let me just grab this and take it to the front, and then you have the factor. Now, as you move along, you can, take these points up. Now, to create the vertical members, what you need to do is now, again, like we discussed in the basics, we have two curves, two set of lists, and we want a line between these lists. So again, what we'll do is we'll take a line command, primitive and line, and from that we take the first list of points, and then we take the second list of the points, and voila, you get these members for the bridge. Now, suppose you want the cross bracings, okay? Like from this point to this point, this point to this point, this point to this point. So what you'll do, I told you a concept of shift list. And if you want, like this list should start from here, and this should start from here instead. So you shift this set of lists with 1 point, and then you join it. So we go to sets, we go to list, and we say shift list. Okay, and then we shift it by 1, and as I told you, we will not say wrap on, otherwise the last point would join from this point, it will go back. So we will make it false. We take this list of points, the second one, and we shift it by 1. Okay, and then we have another line joining. The first point would be this, and the new list of the points would be this. And you can get a very good truss sort of thing. Now, another line which you want is this above one. So what you can do is, these are the moved points, these ones, okay? And if sometimes these wires are confusing, what you can do is you can go ahead and there are wire styles and you can put it to faint, so it will faint out. So what will happen is, like, your script would look very clean and you'll not be confused, like it looks very clean, no? And it's always a secret in Grasshopper to be ordered and organized. It's very nice if you keep it organized and you know, always aligned through using these tools and other things. So these are like always very important. Okay, so now if you want to join these points, you make a polyline through these sort of points, set of points, and then you can just double click from here, or you can go from curves and then you can go to primitives, and then you can have polylines from here. There would be a polyline command somewhere here. Bezier, interpolate. You can take interpolate curves, but yeah, let me just say polyline, and you get a polyline, and then we say Control Alt, and there it is. It's in spline curves command. Okay, so you can take these moved points and you can have the above line also. So now you have a like sort of bridge, you know. And what you want to do is you want to create a similar one. So if you pass this curve into same set of script, like whole script, it will do the same for this curve also. You need to press when you input, press shift when you input two elements into the same component, and then you see for the other one also you have the same amount. And then if you change the number of counts, you can change the number of bracings, you know. And let me take it to a little bit higher, and then change these. Okay, so now what else is left is we need to create a floor, and we need to create like these vertical members on which the floor will be rested. So there should be one more line. Let me take this little down. Okay, and from the two curves, this one. Now thing is, we have two curves. Okay, so we are getting two lists. So this is something trees which we can get later into. So right now, let me not take it, to make it simple, let me disconnect one of the wire. You say Alt and then you okay. So if you say take this and then you say Control, and you can unwire. Okay, so I will take this curve and copy like the whole script, this one, for the reason of simplicity for you now, so I don't have to get into data trees, because that's a different topic and I will be taking that on some different occasions. Okay, so now we have two set of curves, and now we need a point from these and these. So we can have a line. So we can go to primitive curves, and then we say line and line, and then we can say these division points should be matching with these. So we will take a point from here, end point from here, and then you get sort of a web to work on. Okay, and then as the wires, like you can see, they're getting a little confusing. So you can, what you can do is you can make these wires faint again. Okay, so now it's like, and then like you can see all these components are in different position. You can select all of them and then you can align them to the same line and your script looks better. Okay, now you need to get a floor slab. Okay, let me check on your suggestions, please. First, thanks, Sajesh, for your comment. We are trying to just explain you, and if you're following through, it's good for us. And we'll be completing this bridge. Hope all the viewers in the webcast are following. And this video will be online on the blog, and you can later on see it to follow and make it yourself. And you can send us your models also at our page inbox if you get stuck somewhere. But might be this video helps you and you get started with Grasshopper lists and some more things. So let me like all your comments because it's encouraging when people are there when you are webcasting. Yes, Afshin, yes, we can. Our blog name is, our blog is basically, I'm referring to my Facebook page. We don't have a separate blog, but we work on Facebook and we are a community of 3,000 plus people. We have 3,500 followers and around 3,200 people who like us. And our page name is Parametric Curiosity, and you can follow our page to get these videos. Okay, so I'll get back on to the video. Any of your suggestions or like any of your doubts, please you can put it here in the comments and section box. In between teaching you all the stuff, I'll come back and check your suggestions and this comment box. And let me go back to the bridge exercise. Hope you are getting there with this is very simple line work. It's just like how computer works and how list works. Okay, so now you have like these very good bridge structure. Now you need to provide like thicknesses and members. So first thing we'll do is we will create a base platform. How you will create a base platform would be, you know, you will loft these two curves and you will get a surface. So how would you do that is you can take a loft command and you can access this command from surfaces and freeform and then loft. And then you have, it's asking for you for the curves. So maybe you can take these curves also, like these ones. If you loft these ones, these will also fetch you your entrance. Okay, so now you have a base, and now suppose you want to say some members down there. So what you say is, let me just take all these things and arrange my script, because it's very important, as I'm telling you again and again, it's very important to arrange your script always, so that these wires don't dominate your script. It's very important. Okay, and it looks clean, and then you can just, you know, go around very nicely. Okay, so now you have the base. Now what you need is structure around all these members. So what you can do is, when you go to freeform surfaces, there is a very good option called pipe. And what this pipe do is, if you have a curve, it will allow you to pipe it through a circular radius. You can define this radius of the circle and it will create a pipe. So that way, like, you can have, you know, sort of members. So right now, if you want like heavier pipes for the loft, so you will take these lines and then you can say curves and then pipe, and you can see like small structures are there already, but you can set the radius again through the number slider, and then we can take number slider 0.5 to maybe 4. Okay, and for that you click it here. Okay, and then when you increase it, oh, I have done in a wrong one. It should be in the radius one. Okay, so you can see like there are pipes which you can, you know, increase or decrease the size. Now same thing you can do with the curves which we've made. Now suppose if you have like all the curves with the same length, what you'll do is like you don't have to go and take this command for each component. You can merge all these lines. Like suppose when I'm selecting this, how do you get all this into one component? So there's something called merge, which is very important to know. And what it does, it brings you a set of lists into one list. So if you say data 1, data 2, and data 3. So what you'll have is you'll have a list of lines all in one list. Okay, and it shows you like in the first list you have total 27 values. In the first list you have 14 values, and the second list you have 13 values. Okay, so likewise you can take all the lines here. Okay, and then similarly you can do it for the second one. Okay, and we can do it into the same one, and what is left is those two polylines are left, and those two polylines are here, this one, and there is a polyline which you've already taken. So now as you can see you have all the lines, and what I'll do is make it very hidden lines so it doesn't bother you. Faint and wire display, faint, wire display, faint, wire display, faint, and wire display, faint. Okay, so now you have all those. Now you can take this, copy this command, and instead of those curves you can have all these curves together, and you see you have this, and then what you can say is you can reduce these ones. Now if you notice there are some gaps here. These are because we have an option of caps, and caps is right now none. So if you go there and if you say flat caps, like suppose here, if you go here, right click, and if you say flat caps, it will give you flat caps. Okay, and if you want the cappings to be round, like in this case there are 3 or 4 junctions which are here, we can go and we can say round caps. So all the caps would be round, and maybe we make the caps here also round. Okay, so we have a whole set of bridge, and what you can do is in Grasshopper, like this is your final output. Okay, including this one and this one. Okay, So before that, if you take and if you just select all this and hit space, there is a button of enable preview and disable. So if you disable the preview of all the other things would be gone from your model, and only what you'll be able to see is what you want. And if you want to get all this geometry into the Rhino, you need to bake. So these are the pipe structures, this is the loft, and this is the pipe. Select all these with shift command and you say spacebar, and you say shift and bake. And then these are the preview. If you say don't preview any Grasshopper geometry, it will be pure Rhino. And then you can say shaded, and then you have your Rhino model, which is a sort of bridge which we are doing. And then there are, if this is Rhino 6, so you have a new option of called Arctic, which gives you these, you know, illustrious renderings of your model, like how you can do it. And the best part is once you create these systems, this programming, when you say click here and when you come back to Grasshopper and you say this draw shaded geometry, you have your model again. And then this time you can change all the parameters, like suppose you want less divisions, okay, 8 divisions in this one and maybe 8 in this one, okay. So you have another set of configuration. Yes, you can play with the pipe, you know, radiuses, and all the model is really parametric, and that's what the beauty of Grasshopper is. So what we'll do is we'll bake this and we'll disable the preview, and I will say an Arctic preview of this model. And this is pretty much it for the list and other things. And you can, you know, use now new curves also, which I can show you right now. Like suppose your geometry changes, now your site conditions change and your bridge shape change, and you have somewhat bridge like this. You know, okay, so now you can say clear values here and clear values here, okay, and then you can say preview again, and then you can feed in new curves. So set one curve, this one, set one curve, this curve, and then you can say height, and then you have a new bridge, oh mama. And then you can change number of members, like suppose let's take it to 15 for right now and 15 in the other one, okay, and then you have a new bridge which you can make. So these are basically parametric systems, and then again what I'll do is I'll bake them, and I'll just go in here and I say Arctic again, and then within no time you have your new bridge. No, so that's what Grasshopper is all about, and that's much of a bridge exercise from Parametric Curiosity, you know. And what I'll do is I'll just be here, and let me come to the comment section and see. We need video at YouTube where we can find it easily. Yes, I would like to Abel, I would like to tell you there is a channel of YouTube which we run. It's called Parametric Curiosity, and you can find all our videos there. And pertaining to this video, as we are doing it on Facebook, this would remain on our Facebook page, Parametric Curiosity, and you can access it anytime you want, and n number of times you can reverse and see it. And if you have any questions right now of what I taught you, it would be good. like any new suggestions or anything which you didn't follow, any doubts which you want to discuss, it would be my pleasure to answer you. And I'll be waiting for 5 minutes maybe, because Facebook allows you a broadcast of 1 minute and maybe 1 hour, and maybe our hour is going to end soon. But for 5 minutes I'll be here, and you can ask your doubts and I shall reply you for the doubts. And the next video, maybe as people have told us that they want point attractors and other stuff to be taught. Next video we can do about that, and we will put a notification in advance on when we are doing the video with attractor points, and then pretty much you can follow. And I would like to thank all of you who are following this video right now, and who's taken this time out to learn and gather information about parametric curiosity in Grasshopper. It's a pleasure, and thanks for your time basically, because people are busy. And if you have like some time preference also, because we are webcasting from India and we follow Indian time, so we can schedule time according to, if possible, we can do it according to our viewers. But most of all, this is very appropriate time for us, and we'll come back with more videos. And I'm still waiting if you have any other questions. So if you want to just go through the script, I can take you once more through the script. And it's like, this is a line where we started from. I'll just recap, okay? Okay, so this was a line, then we divided this line, we moved the points up, and then we use these points to create these lines. Then we took these points and we shifted the list of these points to get, one less point. If you see this list and this list, there is one lesser point here, okay? And then we joined these points again, and we got these lines and these lines, okay? And then we took a polyline to take this line, and together with that curve, our first structure was complete. And similarly, we repeated this with another set of curves, and then we merged all of them to get a pipe structure. We lofted the basic curves to get this, and the pipes to get the support. So it was a very, very simple script, and there is nothing more. But this shows you like how you can employ lists in your geometric problems. Okay. Thank you. Thanks a lot, everybody. And it's time to say bye-bye, because we are ending our webcast. And it was nice getting some comments from people who are watching this, and it was really wonderful. Thanks a lot, and see you soon again, and we'll bring up more videos. Thank you. Bye.